Okay, so I'm going to talk to you about some different types of functions and how to write equations for those functions. The first thing I want to talk to you about is exponential functions. And we've been talking a lot about exponential functions and what they are, how to graph them, how to manipulate them, but we haven't really talked about how to write an equation of those exponential functions. So just as a reminder, an exponential function is in the form of a times b to the x. And we had some h and k in here where we kind of shifted them around. But as far as writing the equation, right now we're going to stick with the base parent function here, the just a times b to the x, okay? So what I want to do is I want to look at, if we're given 2 points, how do we write the equation of an exponential function of this form, okay? So let's look at an example. Let's say I have the points 1, 6 and 2, 18. And I want to write the equation of an exponential function of this form, okay? So I'm sure you can probably guess what we're going to do, and if not, I'm going to show you and we'll work together, and then I'll give you one to try. So if you think about this being x and this being y, right? And I've got 2 different values. So I'm going to set up 2 equations. First one I'm going to do with the 1, 6. So 6 equals, now notice I don't know a and I don't know b, but I know that x is 1. Okay, so that's equation number 1. Now if I follow the same suit and I plug in the second point, so now 18 equals a times b to the second. So if you notice what I have 2 equations and 2 unknowns, okay? And if you think back to Algebra 1, when I have 2 equations and 2 unknowns, this is called a system of equations, right? So I have to figure out how to solve it. And if you rewind back, there were 2 methods, substitution and elimination. So what I'm really going to look for here is I'm going to try to work with elimination, or excuse me, substitution, I'm sorry, where what I'm going to do is I'm going to solve one equation for a variable and then plug that back in to the second equation, okay? So I'm going to solve one, and I think in this one I'll solve the first equation for a. Well, okay. Now, it'll still have a variable in it, and that's okay. So watch what happens. I take this first equation, and I solve it. So 6 equals a times b to the first. So if I solve it for a, and you don't really need that power of 1 here because that's implied. So the b's cancel out. So I know that by solving the first equation that a has to be equal to 6 over b, okay? So now what I'm going to do is I'm going to substitute that value in for the a in the second equation, okay? So follow closely. I have 18 equals, and instead of a, what I'm going to do is I'm going to replace it with 6 over b, okay? Because that's what a equals, times b squared. Okay, so remembering that whenever I multiply fractions, what I'm going to do is top times top and bottom times bottom. So I get 6b squared over b. And remember those properties of exponents. That means that 18 equals 6b because I subtract those exponents. Now if 18 equals 6b, then we know that if we divide by 6 on both sides, that b must equal 3. Okay, that's a pretty easy solve there. So if b equals 3, remember I had 2 equations with 2 unknowns. So if b is 3, I really need to also find out what does a equal. So I'm going to take this value of b and I'm going to plug it back in. So if 6 equals a times, and now for b I'm going to put in a 3, Okay, and I'm using this one. You could also use this equation that you originally manipulated to solve for a. It doesn't really matter. I'm going to divide by 3, and I find out that a actually equals 2. Okay, so all I've done is solve this simple system for a and b, but I still haven't answered the question. The question was, what's a power function that goes through these 2 points, 1, 6, and 2, 18? Well, if a is 2 and b is 3, that means the equation would be 2 times 3 to the x. Okay, let me give you one to try. Let's say we have the point 1, 8, 2, 16. I want you to write the equation of an exponential function in the form y equals a times b to the x containing these 2 points. Okay, so let's set up our 2 equations here. Let's do 8 equals a times b to the first, and then I will also do 16 equals a times b to the second. So again, I need to solve one of them for one of the variables so that I can use that value to plug back in. I'm going to choose this first equation here, and I'm going to solve it for a. So I have 8 equals a times b to the first. I am going to divide by b to find that 8 over b equals a. Now using this value of a, I am going to take this and it's going into my other equation for the value of a. So now I have 16 equals, not a anymore, but 8 over b times b squared. Okay, so I have 16 equals 8b squared over b, which means that, and I forgot to scroll up, I do apologize, I'm going to have to come over here for you. 16 equals 8b, divide by 8, and I find that 2 equals b. Okay, again, that's only one of the unknowns, so I need to plug in to find a. So I'll use this equation that I already solved for a here to know that 8 over b equals a. So 8 over 2 equals a, which is 4. Again, this isn't the entire answer to the question. The question was, what's the equation of an exponential function? So I use the a, I use the b to say that the equation is y equals 4, b is 2 to the x. Okay. Maybe you think, well, what if that first point didn't have a value of 1? Let's say something like this. I'll give you just a second for you to try and see what happens. Give me the equation of the exponential function containing these 2 points of the form a times b to the x. All right, so let's set up our system. I have 8 equals a times b squared, and then I have 32 equals a times b to the third. So again, I want to pick one to solve. I'll solve this first one for a, and I will have 8 equals ab squared. I'm going to divide both sides by b squared. And so I have 8 over b squared equals a. Okay, so now I'm going to use this plugging back in my second equation. 32 equals, whoop, it's not A anymore. It's gonna be, my buttons right here, 8 over B squared times B to the third. So 32 equals, and if you put this together, you get 8b cubed over b squared, which would be just 8b. Divide both sides by 8, and I find that b equals 4. Okay, back to my equation for A. If b is 4, then A must be 8 over 4 squared, which is 8 over 16, which is 1/2, which I hope you recognize what that means. Y equals 1/2 times 4 to the x. Okay? All right, let's talk for just a minute about power functions, because these were exponential functions meaning x's in the exponent, but we also have power functions. And so what a power function is a power function is when we have the form y equals a times x to the b power, meaning this could be anything, a 2, a 3, a 5, a 10, whatever it is, that exponent there varies, okay? So we're going to follow the same setup, the same scenario. It just may be a little more difficult for you as we set up the equations for the power functions, but let's jump right in and see what we can do. Let's say we have the points. Let me go ahead and scroll up while I'm here. 2, 1, and 4, 3. Okay? And I want the equation in the form this time of a power function, so a times x to the b power. Okay? Same situation, same scenario. I'm going to set up my two equations. So 1 equals a times my x is 2 to the b power. Okay, now stay with me. This looks a little funny, but it's okay because we can still work with it. All right, I'm going to set up my second equation. 3 equals a times 4 this time to the b power. Okay, now because this is going to be really hard and start involving some crazy things if I try to solve for b, I'm just going to stick with what I've been doing and solve it for a. Okay, so when I solve this first one for a, I have 1 equals a times 2 to the b power. I'm just going to divide by 2 to the b power. Okay, so what happens is I get 1 over 2 to the b equals a. Okay, and again, I'm just going to sub that value back in here for a. So I have 3 equals 1 over 2 to the b times 4 to the b. Now watch what happens, because this is over 1. I end up with 3 equals 4 to the b power over 2 to the b power. Now remember, if you think back, whenever we were talking about properties of exponents, we said when you're multiplying or dividing, if the bases are the same, then combine the exponents, but if the exponents are exactly the same, you can combine the bases. So in this case, I can say, well, hey, the exponents are the same, so 4 divided by 2 is 2. So I have 2 to the b power equals 3. Now you might say, Miss McGee, that's still not solved for b, and it's not. But if you think, we have learned a nice little way to solve for an exponent when it's missing, and that would be to use a log, okay? So if I have the log base 2 of 3, I find out that that is actually what equals b, okay? Now, I want to really find out a value here, an approximation, so I'm going to take out my calculator and remembering that change of base, okay, because my calculator won't do a base of 2, what I'm really going to need to do to find b is do log of 3 divided by log of 2 to find a decimal equivalent for b. So when I do this, I get log of 3 divided by log of 2, about 1.58. So b is approximately 1.58. And I do that because what I'm going to do, remember this little equation we had for a here? I need to plug back in that formula, right? I know that a is equal to 1 over 2 to the b power. And now that I know b, I can plug in 1.58 approximately. So if I take my calculator out again, and I do 1 divided by 2 to the 1.58. I have too many parentheses there. There we go. 0.334. So A is approximately 0.334. So now I can go back to my equation and plug in. Remember, it's A times X to the B power. So I get A times X raised to the B power. Okay, let me give you one to try. Let's say you want the equation of the power function of the form a times x to the b that goes through these 2 points. So if you'll take a minute to calculate that. All right, so we'll just run through it together. We'll set up the two equations. 9 equals a times 2 to the b, and 27 equals a times 3 to the b. Again, I'm going to solve one of them. I'll choose this first one. The numbers are smaller, so that normally makes it a little bit easier. I'm going to divide by 2 to the b power. So I know that a is equal to 9 over 2 to the b. Substituting that back in here, I get 27 equals 9 over 2 to the b times 3 to the b. All right. So what I get here is 27 equals, now if I put these together again, I have 9, and I'm just going to write it a little bit differently so you can see. 3 over 2 to the b power. Okay, same thing. And I know that that can go to both, but just because these didn't divide nicely. All right, I'm going to divide both sides by 9 because, again, my goal is to find out what does b equal. And I have 27 divided by 9 is 3. 3 over 2 to the b power. Again, I'm going to change form. So I have log base 3/2 of 3 is equal to b. This one's a little bit more challenging, but I know you guys are doing it correctly. All right, let's do change of base. So log of 3 divided by log of 3 over 2. And I get approximately 2.71. And again, I'm going to plug this value in so that I can evaluate for A using this formula. So A equals 9 over 2 to the 2.71. 9 over 2. Let's put this in parentheses. 2 raised to the 2.71 would give me 1.38 rounded. And so my equation would be y equals A times x to the b. Okay, good job, guys.